Hello and welcome to my YouTube channel Tech Attack, and in this video I am going to talk about feature engineering. So let's get started. So first of all, let me create data for a situation. Say we'll have the time and speed, and we will have another column, target distance. Now, based on time and speed and target distance, we'll have another column called remaining distance. So let's take a typical scenario where we know the time and speed, current time and speed of a car, and we also know uh, the target distance, means the total distance that the car will have to travel to reach its destination. So we know the target distance, we know time and speed, so we can calculate the remaining distance, right? So we'll have like four columns. So let's create that data first. Let's create time. Okay, so we'll be using the numpy random function. Create that by random. So so let's take a sample around 50. Let's see. Okay, sorry, it's not working that way. I think the high value should be around the first parameter for rand is the highest possible value. So let me take the highest possible value, 60 maybe. I think it would be better. So time would be in, um, let's take minutes. Okay, in minutes, and I think there is another variable. Think it is size. Um, no, has to be, yeah, it worked. So we have 50 samples with a maximum value of 60. So next one is speed. Now for speed, we'll also have 60 samples, but let's take the highest value as 100. Okay, so let's take the speed as kilometer per second. So time is in minutes and speed is in kilometer per second. And we'll also have something called target distance and remaining distance. So it is a fact that the target distance should be greater than current distance. So we don't know the current distance yet. So to create the data, let me first calculate the current distance. Okay. So what is the value of current distance? Well, it is the multiplication of time and speed, but the time is in minutes, so we have to convert it to seconds by multiplying it with 60. So it will be like time multiplied with 60 multiplied with speed. So we have the current distance, and then for the target distance, we'll just add some more values to the current distance. So let me simplify this thing. Okay, right, remaining remaining distance. So we'll just calculate the remaining distance. Okay, remaining distance would be let's take the same function rand int. Okay, so let's take it 1000. I think it will be better. Let's take it 1000 and current distance plus remaining distance. So it will calculate the target distance. So we'll have all the values. So all the required values are there. So let's see if there is an error. Now everything is fine. So let's create a pandas data frame from it so that it will look good. I think it's called data, and inside it I'll just give the values of time, and then speed. Speed, and then there is uh, target distance, and then there's this remaining distance. So we have made a data frame out of our generated data. So it has time, speed, target distance, and remaining distance. So say we have a typical scenario where we have to model a machine learning algorithm, machine learning model, which has to predict the value of remaining distance from this given data. Now, the first thing would be to analyze the situation, analyze what is present, and based on that, you have to decide how to model the solution. So, if you apply artificial neural network directly to this data, then it won't work. Let me tell you why. How artificial neural network works is that it will, let's say we have the input layer as I1, actually it starts from 0, right? I1, I0, I1, I2, I3, I4, dot dot dot, and the output layer will have say there is another layer, hidden layer. Say the output of hidden layer would be something like uh, w0 I0, and then w1 I0, w2 I0 will be adding up plus dot 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 w00, w01, w02. After that, sorry, there will be like I1, I2, I made a mistake, I2, I3, and I4. I think you got it right. So again, there will be like W10, I0 plus W11, I1. Actually, they are all W11 is multiplying with I1. I've written it like that. So just understood that. I2, I2 plus. So they are all weighted sum, nothing else. So you can see that if we have to multiply I1 with I2, there is no such thing in the equation. So inside a machine learning, not exactly machine learning, inside that artificial neural network, there is no multiplication between the inputs. There is no multiplication involved between two inputs. Say we have to multiply time with speed to get a get the information about distance, but you will not find any multiplication inside the equation of an artificial neural network. So if you're using artificial neural network directly with that, it is not going to work because it doesn't know the current distance. So it cannot find accurately the remaining distance. So the whatever model you will be preparing directly from that would be useless if you are using artificial neural network. So what is the solution? Obviously, after analyzing this data, you will understand that you will need another column in this data frame called current distance. Now, if you add current distance to that artificial neural network input, then maybe, just maybe, this W00 would turn into 0, W01 would turn into 0, and I say I1 is time. Okay. So it doesn't depend on time, and at the same time it doesn't depend on speed. So it can safely zero out both of them, and it will only take the distance. It will only take the distance, current distance, and then it will take a negative of the target. Sorry, it will be opposite, right? It will take the negative of current distance, and it will add it with the distance, right? The target distance. Why? Because if I just write it before that equation, you'll understand why. So it's like target distance is being subtracted by distance. So target distance minus distance will give us the remaining distance. So what we're doing in that model, our task was to find the remaining distance. So how we have successfully done that? Just by adding another column. So adding that column inside the data is very important, and that's what the task of feature engineering is. We will add another feature called current distance, and that's all. So as a feature engineer, you have to understand how the columns are interconnected, how the time and speed is interconnected. For example, here I have written time is in minutes and speed is in kilometer per second. So we have to understand that so that we can convert the minutes to second by multiplying it with 60. Otherwise, if we don't clearly understand the format of the data and the type of the data, then we'll mess it up. You cannot uh, feature engineer that data set. Now, let me elaborate the importance of feature engineering uh, by giving you a uh, uh, demonstration using TensorFlow playground. Okay, I'll be giving the link in the uh, description box. You can follow it from there. Okay, so this page is TensorFlow playground. You can just click on the play button and it will find a solution to that. Let me explain from the very beginning. Let me pause this thing. So this is the data structure. Okay, so you'll select one data from there. So these are the uh, given data points, and there are some levels like blue is classified as 1 and red is classified as -1. So they are kind of uh, logistic type. Okay, logistic regression problem. So in this playground there is a structure, there is a model which will be solving that problem space. So based on the given inputs, this is the input layer, x1 x2. So x1 is the value of x in the value of the dot in one axis, and x2 is the value of x in another axis, like x comma y. It's kind of like that. Okay, so we're giving two inputs, x1 and x2, and it will just classify it as blue or red. So it is doing great for the first one. Now if we remove the hidden layers, there is only a single hidden layer. Let's take it zero hidden layers. Okay, directly it will be going to it. Let's see whether it see. So we have to add one hidden layer, otherwise nothing will happen. So with a single hidden layer of two neurons, let's run it. So it is having a hard time. If I increase the neurons and play the same thing, so you can experiment with it, the importance of number of neurons, how the number of neurons affect uh, the outcome, and how the number of layers affect the outcome. So you can experiment from there. So the main thing is, say it can solve this problem, right? If I reduce the number of neurons, it gets stuck. Now if I add some inputs, this one is square of this input, this one is square of y, this one is square of x, this one is multiplication of both number, this one is sinusoidal, and this one is sinusoidal of y. So if I add all of them and then click on play, see, it can solve even with a single neuron, I guess. See, so the number of inputs affects that output. Why? Because inside a neural network it cannot multiply or apply sign. Actually, if we give an activation function of sign, there is not this is not given in this list, but if we give an activation function of sign, it can perform that sign transformation, but multiplication will not be there. Okay, so you have to do it manually if you need it. Okay. Say there is a column called time and speed, and you have to there is a dependency with the distance. If you feel like that, then you have to do it manually as a feature engineer. So let me do another experiment. Let me take the most sophisticated one, the spiral one. Okay, let's add a lot of neurons, lot of hidden layers. Let's take up the challenge. Okay, so we are only giving x1 and x2. Okay, the raw input. We are not doing any feature engineering in this, and we are pushing it in this neural network. At this point, it may be called as a deep neural network. Let's see what happens, whether it can solve it or not. So as you can see that how much it tries to solve that problem, it is still struggling. Now if you change the activation function to say relu, let's see what happens. Anyways, it might take a very long time to solve this thing. Maybe it can solve it, maybe not. But the most important part is that if I just apply this one, x1, x2, then there will be an improvement. See, the output result is improved by a lot. Now it is kind of perfect. So just by adding this one, there is such a huge level of improvement. If I just decrease the neurons, with just a single layer of 4 neurons, let's see the result. Now if I just give it 2 neurons and add all those inputs, let's see what happens. So it's kind of like the right amount of input with the right amount of neurons that will help us to solve the whole thing. Both are necessary equally. Let's add another layer. Yeah, it has stabilized in the state. So it's like that. So in feature engineering, what you will do is you will be given x1 and x2, but if you feel the need for x1 square and x2 square, or x1 x2, or sine of x1 or sine of x2, etc., you will just find them, you will calculate them and place them in the input. And if you feel some of the features are unnecessary, say these two are unnecessary, and you feel like this one is also unnecessary, then this is also a part of feature engineering. Like you will strip off the unnecessary part. Okay, so this is for this video. See you again in my next video. Bye.